Imagine the quantum world as a puzzle box full of strange and wonderful things. This box is not just any ordinary puzzle, it's a gateway to a realm where the rules of reality as we know them are turned upside down. The pieces of this puzzle are not static, they are dynamic, constantly shifting and changing, defying our conventional understanding of how things should behave. In this tiny world, things aren't so clear. Particles behave in ways that seem completely illogical. They move unpredictably, as if they have a mind of their own, and their exact position and momentum can't be determined simultaneously. This is the essence of Heisenberg's uncertainty principle, a cornerstone of quantum mechanics. Particles, like tiny specks of energy, don't follow the usual rules. They exist in a state of superposition where they can be in multiple states at once until they are observed. This means a particle can be here, there, and everywhere in between, all at the same time. It's a concept that challenges our very perception of reality. They can be in two places at once, a bit like a magician's illusion. This phenomenon, known as quantum entanglement, suggests that particles can be instantaneously connected no matter the distance separating them. It's as if they share a mysterious bond that transcends space and time. This is the realm of quantum mechanics, where the common sense of our large-scale world starts to break down. Here, particles can behave both as particles and waves, a duality that defies our everyday experiences. This wave-particle duality is a fundamental aspect of quantum theory, revealing the complex and often paradoxical nature of the quantum world. One of the most baffling puzzles in this quantum box is the idea of retrocausality. This concept suggests that events in the future can influence events in the past, turning our conventional understanding of cause and effect on its head. It's a topic that has intrigued and perplexed scientists and philosophers alike. It's a mind-bending concept that suggests the future might influence the past. Imagine a world where your actions today could be shaped by events that have yet to occur. This idea challenges the linear progression of time and opens up a realm of possibilities that are as fascinating as they are bewildering. Imagine throwing a ball and then realizing you chose to throw it based on where it landed. This thought experiment illustrates the perplexing nature of retrocausality, where the effect precedes the cause, creating a loop that defies our traditional understanding of time. That's a bit what retrocausality feels like. It's a concept that stretches the boundaries of our imagination and challenges the very fabric of reality. As we delve deeper into the quantum puzzle box, we uncover more questions than answers, each piece revealing a new layer of complexity and wonder. Retrocausality, put simply, is the idea that an event in the future can have an effect on something that happened in the past. Imagine a world where the future isn't just a consequence of the past, but an active participant in shaping it. This concept challenges our traditional views of time and causality. It's like saying your current actions could ripple backward in time, changing something that already occurred. Picture dropping a stone in a pond and seeing ripples not only move outward, but also inward, as if the water remembers the future splash. This messes with our everyday understanding of cause and effect, where causes always precede their effects. In our daily lives, we see time as a one-way street, moving from past to present to future, but retrocausality suggests a two-way interaction where the future can influence the past. This isn't time travel in the science fiction sense. We're not talking about hopping into a time machine and visiting ancient civilizations or futuristic worlds. Instead, it's about a more subtle and complex interaction. We're not talking about sending messages to our past selves or altering historical events. The idea isn't to rewrite history, but to understand how future events might cast a shadow back in time, influencing the present in ways we're only beginning to comprehend. Instead, retrocausality in quantum mechanics is about subtle influences that might operate between events separated by time. Quantum particles, for instance, might be entangled in such a way that their states are connected across time, not just space. It suggests that the future, in some strange way, might be able to talk to the past. This opens up a realm of possibilities for how we understand the universe, potentially leading to new technologies and insights into the nature of reality itself. The implications of retrocausality are profound, challenging our deepest assumptions about time and causation. Let's imagine a photon, a tiny particle of light approaching a crossroads. It has to choose between two paths, a bit like a car at a fork in the road. In the quantum world, the photon doesn't just pick one path. Instead, it travels down both paths simultaneously, existing in a blurry state of both possibilities. This is where retrocausality throws a spanner in the works. What if the photon's choice of path is somehow influenced by a measurement made in the future, after it's already gone down both paths? It's as if the photon knows what's going to happen before it happens, challenging our intuitive sense of time and order. One experiment that hints at retrocausality is known as Wheeler's delayed choice experiment. Imagine our photon again, but this time, after it's already traveled down both paths, we decide at the last moment how to measure it. It's like setting up the finish line after the race has already begun. The results of this experiment are mind-boggling. It's as if the photon somehow knew how we were going to measure it, even though that decision was made after the photon had already made its choice of paths. It's as if the future measurement reached back in time to influence the photon's past behavior. Section 5. Quantum entanglement, spooky actions role. Another piece of the retrocausality puzzle might lie in the strange phenomenon of quantum entanglement. Imagine two photons linked in such a way that they share the same fate, no matter how far apart they are. If you measure one photon and find it spinning one way, you instantly know the other photon is spinning the opposite way. Einstein famously called this spooky action at a distance. But what if this spooky action isn't just about distance, but also about time? What if the measurement of one entangled photon could instantly influence the state of its partner, even if that partner existed in the past? Section 6. Can we change the past? The idea of retrocausality raises some fascinating and potentially disturbing questions. If the future can influence the past, does that mean we have no free will? Are our choices predetermined by events that haven't happened yet? Could we potentially change the past by altering the future? It's important to note that retrocausality is still a highly debated theory within physics. There's no definitive proof that it's real, and many physicists remain skeptical. The experiments that hint at retrocausality can also be interpreted in other ways that don't require messing with our usual notions of time. Section 7. A universe upside down? If retrocausality is real, it would require a radical rethink of our understanding of the universe. It would mean that time is not a one-way street, but a more fluid and interconnected dimension. Cause and effect might become blurred, with events in the past and future influencing each other in a complex dance. Our everyday experience tells us that time moves forward and the past is fixed. But what if our perception of time is just that? A perception? What if the universe at a fundamental level operates with a very different understanding of time than our human minds can grasp? Section 8. The unanswered questions. The possibility of retrocausality throws up more questions than answers. How could the future possibly influence the past without violating our understanding of causality? What are the implications for our understanding of free will and determinism? If retrocausality is real, how can we reconcile it with other fundamental laws of physics? These are not easy questions to answer, and they're likely to keep physicists and philosophers debating for many years to come. But the very fact that we can even ask these questions demonstrates the incredible power and mystery of the quantum world. Section 9. The future of time's secrets. The exploration of retrocausality is still in its infancy. This concept, which suggests that future events can influence the past, is both fascinating and perplexing. Scientists are only beginning to scratch the surface of what this could mean for our understanding of time and causality. New experiments are being designed, pushing the boundaries of what we know. These experiments often involve cutting-edge technology and innovative methodologies aiming to capture the elusive evidence of retrocausal effects, and theoretical models are being refined to better understand this mind-bending concept. Researchers are constantly updating their models to incorporate new data and insights, striving to create a coherent framework that can explain how retrocausality might operate in the quantum realm. Quantum computers, with their ability to harness the strangeness of the quantum world, might offer new tools to probe the mysteries of time. These powerful machines can process information in ways that classical computers cannot, potentially revealing hidden aspects of time and causality. One thing is certain: the journey into the quantum realm has only just begun. As we continue to explore this frontier, we are likely to uncover phenomena that challenge our most fundamental assumptions about reality. As we delve deeper into the heart of reality, we are not just looking at the microscopic world of particles, but also at the vast expanse of the cosmos. The interplay between the very small and the very large could hold the key to understanding time's secrets. We can expect to encounter even more strange and wonderful phenomena that challenge our understanding of the universe and our place within it. Each discovery opens up new questions and possibilities, driving the quest for knowledge ever forward. The future of physics, it seems, might be found by looking not just ahead, but also behind us, into the enigmatic depths of time itself. By studying the past and its potential connections to the future, we may unlock secrets that have eluded humanity for centuries, paving the way for a new era of scientific discovery.